Hello students, in this session we will be studying about DBMS languages. Here we have two things, one is DDL and another one is DML. Once the design of a database is completed and a DBMS is chosen to implement the database, the first step is to specify conceptual and internal schemas for the database and any mappings between the two. In many DBMS, what happens is where there is no separation of levels, one language, that is a data definition language, is used by the DPA and by database designers to define both the schemas. Right? We have two kind of schema, that is conceptual and internal schema. For that reason, we can make use of DDL only. Then we have DML, data manipulation language. As the name says, manipulation is nothing but either the insertion, deletion, or something. We will be making use of DML. Here we have again two things: high level or non-procedural language. Right? These are nothing but this include the relational language like SQL. It may be used in a standalone way or may be embedded in a programming language. Then we have another one is low level or the procedural language. This must be embedded in programming language only, which cannot be worked as a standalone one. Once again, we will be studying about a data definition language in depth. It is used by the DBA and the database designers to specify the conceptual schema of a database. Whenever we want to define the conceptual schema, we can make use of DDL. In many DBMS, what happens is the DDL is also used to define internal and external schemas as well. Right? External schemas are known as views. In some DBMS, separate language known as SDL, that is storage definition language, is used for explaining in depth regarding how the information is stored and all. Then we will be making use of VDL, that is view definition language, which is used for defining the internal and the external schema. SDL is typically realized via DBMS commands provided to the DBA and database designers. Right? Whenever we want to deal with any SDL, we can make use of DBMS commands which are available with us. Then we have data manipulation language. DML is used to specify database retrievals and updates. Whenever we want to make any updates or we want to get back the information that is already stored, we'll be making use of DML. DML commands, they are also known as data sublanguage, can be embedded in a general purpose programming language. We call it as a host language such as COBOL, C, C++, or Java. Here what happens is we can make use of any of the high level language like COBOL, C, C++, or Java. Then what we can do is the commands, DML commands, the specific commands, we can embed in that particular language and we can make our work done. A library of functions can also be provided to access the DBMS from a programming language. Alternatively, what we can do is standalone DML commands can be applied directly, called a query language. Right? SQL commands directly can be used for updation, deletion, all these things. Then we have types of DML. High level or non-procedural language. For example, SQL relational language is an example of high level or the non-procedural language. And they are set oriented and specify what data to retrieve rather than how to retrieve it. Here we will not make use of any commands which tells us like how to retrieve it. What we will be telling is what content has to be retrieved, and it is set oriented because a set of things are extracted when we want to extract it, and it is also known as declarative language. Right? High level language, or we can call it as non-procedural language, or we can call it as declarative language, and it is also known as set oriented language because when we want to extract some information, we'll be getting the answer in terms of sets. Then we have low level or the procedural language. Here retrieving of data happens in record at a time. That is, whenever we are extracting some information, we'll not get whole information in the one go. Here what happens is a single set we are getting as a output. Here constructs such as looping are needed to retrieve multiple records along with positioning pointers. Here two things are required. Whenever we will make use of low level or the procedural language, we require two things. One is looping construct. Either we can make use of for loop, while loop, whatever the loop we are having. We will be making use of a looping construct. Apart from that, we'll be making use of a positioning pointers, because after one thing has been retrieved, we have to know like what is the next thing that has to be retrieved, right? So we'll be making use of a positioning pointers. Now we will see about the DBMS interfaces. The interfaces are the medium through which we can get the information through the database. Here basically we have three kind of interfaces. One is standalone interface, then we have programmer interface, the interface which is used by the programmers. Then we have user-friendly interface for the normal people. First we'll be looking at the standalone query language interfaces. Right, here we can give an example of SQL, right? Entering SQL queries at the DBMS interactive SQL interface, which is SQL plus in Oracle, right? If you are making use of Oracle, then there is a interface known as SQL plus interface through which we can make use of this interface through which we can access the database, right? Then we have another one kind of interface which is used by the programmers, right? Programmers program the things, and the normal people make use of this in this data. Programmer interfaces for embedding DML in programming languages, which we'll be seeing in the next slide, right? Then we have user-friendly interfaces which are easy to use, right? Like a menu-based, form-based, graphics-based, which we'll be seeing in the next slide. First, let us see about DBMS programming language interfaces. Here, these are the interfaces, as I already said, which are used by the programmers. Programmer interface for embedding DML in a programming languages like embedded approach. Either they can make use of embedded approach or procedural call approach or the database programming language approach. First one about the embedded approach. In embedded approach, what is going to happen again is, as the name says, embedded, it will be embedded in some language, right? Either C, C++. Suppose if you are making use of C, C++, then we can make use of normal SQL over there. Then SQLJ is used for Java. Suppose if you are making use of host language as Java, then SQLJ approach is used for embedded approach over here. Then we have procedural call approach. In procedural call approach, we can make use of JDBC for Java and ODBC for other programming language. If you are making use of other programming language, then you can make use of ODBC, or else if the Java is the language that you have considered, then JDBC is the procedural call which you will be making use of. Then we have database programming language approach. Example, Oracle. Oracle make use of its own programming language like PLSQL. Then we have language incorporates SQL and its data types as integral components. User-friendly DBMS interfaces, right? First one is the menu-based interfaces, which is popularly used in the web browsing. Whenever we are browsing through the web, here we'll be having a menu base, right? When we click on a particular menu, we'll be having a lot of things. Drag, drop-up menu will be available over there. When we click on that, some instructions are carried out internally, right? So that is a menu-based interface. Then we have form-based interface, which is basically built for the naive users, right? Here what happens is, here will be getting a form. In this form, we'll be inserting the data at the respective fields. Then when we click submit, then it will be storing it in a database. Then we have graphics-based, wherein point and click, drag and drop, etc. This is an example of a graphic-based interfaces. Then we have natural language interface, wherein request is written in English language, right? We can make use of English language, wherein when we want to give some commands and all, it can be written in a normal sentences. Then the sentences are matched up with the inbuilt things, right? Then when we write a particular sentence, if you want to insert the things, we can write insert in so and so table, all these things. We can write it in a normal language, natural language. Then it will be converted into a particular query, which will be accessing in the background. Then we have a combinations of the above. What we can have is, in a particular application, we can have combination of all the things, like some can be a menu based and other part can be a natural based, and other can be a graphics based interface. We can mix up all these things and we can have a single interface. Other DBMS interfaces are speech as input and output. Here what we will be having is, we will not type anything over there, just we'll be giving the commands in terms of inputs. Input will be in terms of a speech. We'll be giving something as input. We'll be speaking, that will be converted as a command and which will be executed in the background, and we'll be getting the information again in terms of speech only. Right, then we have web browsers wherein we can make use of this web browsers for interacting with the database. Then we have parametric interface, for example, bank tellers using the function keys. Here we can make use of a particular key. When a particular key is used, what happens is a particular task will be carried out. Like if I want to save, then when I have a prefixed function key, then what happens is when I click on that, automatically some action will be taken in the background. Right. Then apart from that, we have interfaces for the DBA. DBA make use of interfaces for creating the user accounts, for granting the authorizations, then setting system parameters, changing schemas or access paths. So these are the work of the DBA. For him, we can make use of a different interface. Database utilities. To perform certain functions such as loading data stored in files into a database, right? We can have our file, then directly we can store it in a database, which includes data conversion tools, because the data that is in a format which will not be processed in the database, it has to be converted into a particular format, then only we can process the data. Then we have backing up the database periodically on tape. Whenever we are storing some data on disk, what happens is there might be some failure, because of which we are not able to get back the information. So periodically data is stored in a tape. Whenever if disk fails or something happens, then we can retrieve back the data that is present on a tape. For that reason, we have a different utility tool. Then we have reorganizing database file structure. As I said, when we are migrating from one database to another database, what happens is the format will be different. So we can make use of reorganizing database file structure for this. Then report generation utilities. We have a lot of data with us. Now we require some automatic tool, right? When we make use of this particular automatic tool, then that tool will be generating us the reports in a format that we require. Then performance monitoring utilities. Here what happens is we want to monitor the hardware, whatever the software we have with us. It has to be monitored properly, or else what happens is if it is not working, then whenever we are in an urgency or something, then if a particular either the hardware or the software is not working properly, then we will be wasting much of time over there. Then we have other functionalities such as sorting, user monitoring, data compression, etc. For all the things, we have a different utility tools. Apart from those, we have other tools like data dictionary or the repository, which is used to store schema descriptions and other information such as design decisions. Like when we build a particular database, we will be taking some decisions, right? Based on a decision, by having a interaction with the various stakeholders, a particular design will be finalized. Why this design was finalized? What are the things behind this diagram? All the things we will be storing it in a particular place, right? That is a repository. Then application program descriptions, user information, user standards, everything will be stored on a particular repository or the data dictionary. Then here we have two kind of dictionary. One is active data dictionary and another one is passive data dictionary. Now we will be seeing who will be using this active and the passive dictionaries. Active data dictionary is accessed by DBMS software and users or the DBA, right? These are the people who are making use of this active data dictionary. Then we have passive data dictionary, which is used by the users or the DBA only, and this is not used by the DBMS software. Apart from this, we have application development environment and case. That is, case is nothing but computer aided software engineering tools. Here we have tools like Power Builder, which is developed by the Sybase. Then we have JBuilder, which is developed by Borland. Then we have JDeveloper 10G, which is developed by the Oracle. So these are all the tools which will be making use of for developing an database application. Now we will look at typical DBMS component modules. This is one of the important question. Explain the component modules of DBMS and their interactions. Right. Now we will see what are the different kind of users over here. We have users at the top like DBS staff, casual users, then we have application programmers, then the parametric users. So these are the different kind of people who make use of this database. Right. First we will look at the DBA staff. DBA staff has two roles. One is DDL statements, writing the statements for creation of the database. Database statements are being written by the DBA staff. Apart from this, we have privileged commands, right? Granting, revoking the author, revoking the things and all, right? Which will be the work of the DBA staff. In detail statements, we have creation or creating the database, deleting all the things, which is carried out by the DBA staff again, right? Whenever a DDL statement is written, we will be making use of DDL compiler. DDL compiler will understand the things and whatever the database that is being created, which will be stored in a system catalog or the data dictionary. Then we have casual end users. They make use of interactive query for querying the things, right? Interface that is used as interactive query interface is used over here. Whenever a query is being written, it will be passed on to a query compiler. Then we have below query compiler, we have query optimizer, which is going to optimize the things, right? If you are writing a particular statement, which will be rewritten in a such a way that the query is optimized, right? Then we have application programmers who are going to write the applications, right? They are going to develop the applications, and when they are developing applications, they might be making use of two kind of things. One is DML things, and apart from that, host language statements will be there. Here we'll be making use of pre-compiler. Pre-compiler first it segregates DML commands and the host language commands. Whenever it finds a DML command, it will be passing it to the DML compiler. Then we have host language compiler, which will be compiling the statements written in a host language. After both the things are done, then we'll be having a compiled transactions. Okay. Then apart from that, we have parametric end users who are going to make use of a database. How they are making use of databases? They will be provided with the pre-compiled transactions. Directly they will be giving the inputs to that, and they can make use of the database. Then we can see there is a runtime database processor. The work of runtime data processor is to process the things, right? Whatever the commands that are being given by the DBS staff, that will be processed over here. Then casual end users, they'll be writing something, and that will be processed by this. Again, parametric end users and all application programmers, whatever the query they passed on over here, that will be reaching this runtime's database processor, and which will be processed, and then the data will be stored in the database. If you want to store the data, then we can store it, or else if you want to retrieve the data, then also we can make use of this stored database, wherein actual information is being stored. Then we have system catalog or the data dictionary, wherein all the information like schema information, the metadata is present in this. Then we have store data manager, which is working as a manager for controlling the redundancy, and if in quick something has to happen, then this stored data manager will take care of that. Then concurrency control will be there, then backup, recovery, subsystem, everything is present over here. So this is your typical DBMS component module. Thank you.